So here we have an HCl, right? If I dissolve in water, it will produce your H positive and Cl negative ion. So any substance which furnishes the H positive ions in the aqueous medium is called an acid. This acid furnishes H positive ions in aqueous medium. Right? How many H positive ion is it giving? One. So we call it a monobasic acid. And you can see that I am using here one single arrow. It means this reaction is going only in the forward direction. So this is a strong acid. Right? What about this one now? Sulfuric acid. How many H positive it can give? 2. So this is a dibasic acid. It is giving 2 H positive ions and it is again a strong base, strong acid. And if I give you another example of acetic acid, right? It is again a monobasic acid.
But it's weak.
Yeah. How do you know that it is a weak acid?
Because it can go in both ways.
Yeah.
It's reversible.
Its system is in the state of equilibrium. Where we can say the rate of the forward process is equal to rate of the backward process. It means its dissociation and recombination is occurring simultaneously in both the directions. It's a weak acid, right? And base is a substance which donates OH ions in aqueous medium. Can we give an example?
Sodium hydroxide.
Very good. So upon dissociation, it will give here Na positive and OH negative ion. So the substance which provides OH ions is called as a base. Right? It is a strong base.
Yeah.
And it is a monoacidic base. Can you tell me why I am using here monoacidic?
Because it only gives one OH ion?
Yes, it is giving only one OH ions. And if I say I have MgOH whole twice and it is undergoing dissociation like this, magnesium 2 positive ions and the 2 OH ions. So we call this is a strong diacidic base. Right? No. Now define this base.
That's a strong monoacidic base.
It is a weak monoacidic base.
Oh, because
Yeah, so it is a weak,
extra possible.
right? Monoacidic base. So that's the definition of acid and a base, right? And what is pH scale? Do you know something about the pH scale? Yeah.
Yeah.
Yes.
It's the pH scale is used like
Mathematically,
say
if I
how
say
strong.
negative logarithm of H positive ion, do you know the log table something? Mathematics?
No.
Okay, no problem. The point here is very simple, that greater the concentration of the H positive ions, lesser is the pH.
Like the correlation between them.
Yeah, and more acidic that compound is. Right? It means the compound which gives more H positive ion is having less pH and it is more acidic. Right? For example, if I compare here HCl and HBr, and we find that HBr is more acidic, it means the pH for the HBr will be less. Right? So pH is a scale to define a compound is acidic, basic, or neutral, or more acidic, or less acidic. Right? If the pH is equal to 7, it is taken as a neutral. If pH is less than 7, then it is a
Acid.
If the pH is more than 7, it is a
Base. Is there a difference between an alkali and a base?
Yeah, I'll discuss about it. Base is a substance that neutralizes the acid by combining with the H positive ion. And alkali is a substance which donates OH ions in the solution or as a proton acceptor. Alkali, right? And now I'll talk about the same coming to the acidic or basic, right? Suppose I say I have two acids here. One acid has pH of 3, other is 4, right? Can you tell me out of these two which is more basic?
More basic would be 4.
Yeah, more basic would be 4. Even though it is in the acidic range, but it is more basic. Right? And this is more acidic. Can I say the more acidic means less basic?
Yeah.
More basic means less acidic? Okay. Another pH that I have is 9 pH and 11 pH. Out of these two, which is more acidic?
9.
So I can say this is less acidic. So we can say this is more basic and this is less basic. Any doubt here?
No, I understand that. So, except that an alkali dissolves or no?
Yeah.
It's soluble.
Yeah, of course.
So, does a base have to be soluble?
Yeah.
No.
Not necessarily.
Oh, it does? No.
See, alkali and base both are soluble. Right, but alkali is a source of OH ion.
Okay.
And it can be a proton acceptor also. But base is a substance which neutralizes the acid by combining with the H positive ion in them.
But doesn't alkali do that too?
Yeah, it's the same thing basically. Alkali and base of both are same thing basically.
Okay. Okay.
And now we come to this acid, right? So acid contains at least one replaceable H. In all the organic acids, only the H bonded to the O is replaceable. So in the hydrochloric acid, nitric acid, sulfuric acid, ethanoic acid, phosphoric acid, all these are proton donors. So all of these are acidic in nature. Can you tell me among these, which is a dibasic acid?
Sulfuric
Yeah,
acid.
very good. And what is the basicity of the phosphoric acid? You know what the basicity?
Tribasic?
Yeah, tribasic in nature. Basicity means how many H positive ion it can provide. Right. Now, alkali is a source of H positive ions. It contains at least one H. Right. So all these are acidic in nature. HCl, nitric acid, sulfuric acid, they are providing the H positive ions. And more the H positive ion concentration, lesser the pH value and more the acidic character.
Yeah.
Right. And base is a substance which neutralizes the acid by combining the H positive ion. So metal oxides, metal hydroxide and ammonia, these are the bases. Right. Where the alkali is a soluble base, it's soluble base. Alkali means soluble base, which provide OH ions a solution and provide an proton acceptor, right? So group 1 metal hydroxide, ammonia, water, metal carbonate, all these are alkali, right? Alkali dissolved in water, NaOH to give Na positive and OH negative ion, right? Or sodium carbonate, when combined with water, it produces NaOH and sodium bicarbonate. So this sodium carbonate is a base, right? So what is neutralization? Can you tell me what is the meaning of neutralization?
When you mix or add a solid in an acid in a base.
Yeah, they neutralize each other and both their character is lost. Acid loses its acidic character, and base loses its basic character, and we get salt and water, right? So copper oxide is a base. It combines with sulfuric acid to produce copper sulfate and water. Sodium hydroxide, when react to the HCl, both loses their property. Right? HCl no more remain acidic, NaOH no more remain basic, but both become neutral now. Am I clear? 100% clear? Now, can you tell me what is the meaning of the word titration? You might have done in the lab sometimes.
Yeah, we did. When you gradually add an acid to a base, or the other way around.
Yeah.
So it neutralizes.
Yeah. That. So
to see how much of an acid or alkali you need to neutralize it.
Yeah. So do you know what is this apparatus known as? This long tube.
The burette.
Yeah. And then conical flask. Right. So how do you put like acid or base in a conical flask? By which apparatus?
What do you mean?
Means there's an instrument like this. You suck the liquid up to this mark and then put it in the conical flask.
Oh, okay.
So what do you call this instrument?
Oh, like a pipette?
Yeah, pipette, right. So through the pipette, we suck in the acid or base and put it into this beaker, and then we add here one indicator. Do you know what is an indicator?
No. Oh, is it phenolphthalein?
Yeah, phenolphthalein. So basically what happens that this phenolphthalein in the acidic medium is colorless. It means if I add here this phenolphthalein, and put it into the acid like acetic acid, right? The resulting solution remain colorless. But if the same phenolphthalein is added to some base like sodium hydroxide, that becomes the pink in color, right? So in this beaker we have an acid like HCl, an indicator that is phenolphthalein. Can you tell me what will be the color?
It will be light red.
It will be colorless, simply. It will be colorless.
Oh, so then when it's...
Yeah, and now here I have a burette, and from the burette I am adding here sodium hydroxide drop by drop. So drop by drop this liquid goes in and neutralizes the acid. When all the H positive ion from the HCl is neutralized by the NaOH, the end point will come, and now the extra drop will make the whole thing as a basic, and that will turn to pink. It means the appearance, the pink color here, appearance of the pink color, right? Pink color is coming here. That indicates that that neutralization is now complete. Right?
Yeah.
Any doubt?
I understand.
So how do you perform this one? We take a pipette and put into this flask. Then we fix up the burette, and drop by drop we add it, right? So titration is a technique to follow the course of neutralization reaction between acid and an alkali, right? And that's the whole procedure we have discussed now. How to take the reading, that is all okay, right?
Yeah.
Okay. Now from this page, acid, alkali, base, neutralization reaction, salt, titration, just go through it and let me know if you find any doubt.
No, I get it.
Okay.
I think you started with the second one. Let me send you part 1 again.
Yeah, this thing we have not discussed. Now, I told you the pH equal to 7 means neutral. pH more than 7 will be basic, alkaline, and pH less than 7 will be acidic. Greater the value above 7, more the basic nature, more the alkaline nature, and lesser the value before 7 is the acidic in nature, right? So different compounds have a different pH value. You can see the 0 to 3 is strongly acidic, 3 to 6 is weakly acidic, neutral is pH 7, and so on, right? So how to measure this pH? For that we are using some pH meter and using the indicator papers. The scale is from 1 to 14, right? So indicator is a substance that has a different color in different pH value. Right.
Can you have like a midpoint like pH? So if you were to mix like a pH 3 and 4, would it be a pH 3.5 or would it just be like one of them?
Upon calculation, it will come out to be equal to 3.7, but that calculation is not in those labels.
Okay.
Of course, it will be somewhere in between, but not exactly in between.
Right.
Right? Okay, so we have a different indicators here, like litmus, methyl orange, phenolphthalein, universal indicator. So litmus is red in the acidic medium and blue in the alkali medium. Neutral, purple color, litmus. Right? Methyl orange is red in the acidic and yellow in the alkali. And the neutral is orange. Phenolphthalein is colorless in the acidic, pink in the alkali, and it is pale pink in the neutral. And indicator, universal indicator, is red in the acidic, blue in the alkali, and green in the neutral. So this chart you have to remember. Universal indicator is itself color is green, right? Because it contains mixture of indicators. So define it out on this page: acid, alkali, base, pH, indicator.
No, I get all of that. No.